Yeah, thanks again. I wanted to thank everybody who's on the call. My background is in application modernization, infrastructure, and data. Been with Google several years, and I support a large variety of clients from those perspectives. One of the things that we're seeing more and more today, as we talked earlier, is security, and where which is one of the reasons why this talk is really around DevSecOps and not just DevOps. When you look at going forward, some of the top priority challenges that companies are facing, performance and flexibility in terms of agility and building solutions quickly is the number one, but right behind it is security and compliance. And we touched on that just a little bit in the last call or conversation about GDPR, and the need to have, maybe data residency requirements, things like that, and to know that you can prove that in case you get audited or have compliance people come. So when you start looking forward to, the other areas that is cyber security challenges that are hitting cloud environments. As you move your data, as you move your different compute and storage to the cloud, you're running into a variety of malware, supply chain attacks, and things like that are causing delays and also influencing or negatively impacting your social brand, and as it relates to that. When from a Google perspective, if you look at the cost, and this is, for industry, there's a large different variety of costs, and depending on the attack or the type of security breach, you might have different problems or things. But oftentimes you're going to experience downtime. You're going to experience impact to your brand. It's going to get tweeted about. It's going to get on in the newspaper. It's going to get in Facebook. It's going to be everywhere in many cases, and there's going to be a loss of trust. There's banks that have lost customers because of breaches. There's grocery stores and retail companies that have lost customers because they've had to report data breaches and people no longer feel safe. On and on as we go forward. This is going to become a bigger and bigger concern for a lot of organizations, security, and making sure that not negatively impacting their brand. Compromised regulatory status, being failing to meet compliance and getting fined. There's large companies that are I don't want to speak to it directly, but there's several large companies that have recently had this happen. So, security is part and parcel of, DevOps in going forward, and one of the things that, a lot of organizations do is they take more of a castle approach to defense in terms of security. You build a wall, firewall or other walls around, but oftentimes you don't look at the exploitation of data or other data privacy or what's happening with internally, or even phishing attacks that then expose you to other things. Your users or your workforce is mobile. In many cases, you're working you're working at home, or you're working in cafes, things like that, where people, you don't necessarily think as a user that people have access to your machines, but you never know if your actual compute machines get hacked. Inside threats, things like that. So, from our standpoint, from a Google standpoint, we're strongly a player in the security space, and we think that you have to design and implement security from a 21st century standpoint. That you have to look at multiple areas, threat areas, and attacks. You have to make intelligent, centralized access to real-time dashboards and systems to allow you to quickly identify and curtail any types of attacks, and also the ability to take the feedback loop. As a part of DevOps, as often you take blameless postmortems and other things, you have to include security in these conversations as well, so that as you go forward in security breaches, you have to learn from the lessons of others as well as from yourself. So, from a DevSecOps standpoint, the difference between DevOps versus DevSecOps is really about adding security as a core member of the team, the development, the IT operations, the application delivery, and making security a first tier player in that. That from the standpoint of the first user story or use case that you create, there's security and testing involved in that to verify that you've covered and identified any possible threats and that you learn from it. There's the need to have in your whole sprint plans and other strategies, your CI/CD pipelines incorporating security as a part of that. Looking at the third-party code in terms of Google has a product called binary authorization as an example that looks at third-party code and to determine if the containers that actually are being built have threats that have already been identified from some profile or database. Making certain policy decisions across the board in terms of, having maybe limiting public IPs or deactivating certain OS policy or OS permissions so that no one has access to the kernel for example, for VMs, things like that. But again, it's a part of, DevSecOps is looking at it from the holistic viewpoint, from the user creation of the story, the product manager or product owner creation of the story, all the way to what the operations team do to monitor and deploy these new applications or these new services, microservices. When you look at it at more of a tactical level, I'm going to go through some of the capabilities and things in a GKE cluster or Kubernetes Engine cluster. And if you think about, from a standpoint of Google, we're going to talk about some of these areas. We're going to look at the shared security model that we have in place. We're going to look at the container security 101, some of the infrastructure security, network security policies, things like workload, and talk about how they help with DevSecOps and also help with securing your workloads. So when you think about the threats in the wild, there's a lot of things that are somewhat set in the clear. Passwords, configs are often, set in the clear or can be easily decrypted. You have different watchers and sniffers that are in networks that are easily able to collect data about your configurations as well as the users and collect them. You have you might be using public images with embedded cryptocurrency mining malware. We have clients who have seen where they've deployed microservices or VMs, and the next thing you know, their services are being used to be miners, things like that. So these are some of the areas that some of the areas that can be exploited from a standpoint of security breaches and loss of trust from an end user or client. From a security standpoint, when we talked, as I mentioned earlier in our list, we first talked about a shared security model. The first thing is making sure that between the Google as the cloud provider and the client or the application provider, that they understand and we understand the areas. So depending on the type of technology, obviously if you're on-prem, everything is under the ownership of the company managing that solution or service. But as you go to IaaS and PaaS and SaaS, the level of responsibility in terms of access and usage, deployment, web security, to prevent, say, denial of service attacks, things like that, becomes more shared. For example, there's a product that Google has called Cloud Armor that's used to help with denial of service. But there's still things that you can also do as a part of your own setup, as a part of your microservices to, certain patterns that you can implement to avoid those things as well. So, but, using a combination of managed services or cloud provided services and pretty much all cloud, I would imagine the top 5 clouds have similar capabilities for networking and, other areas, data security, encryption. In the case of Google, we have this Google, when you transmit data, it's encrypted in rest and it's encrypted in transit. That's by default. So a lot of these things, from a Google standpoint, are built in, but as a DevSecOps team, you have to validate across each of the cloud how they do it, what they do, and make sure you have common policies that span all clouds that you're working in. Oftentimes, you're working in one cloud and consuming services from another, maybe through APIs, maybe through integrations that you may want to also add to your shared responsibility matrix. So when you think about some of these threats and the threats that are, to containers as an example, from a standpoint of Kubernetes security features to protect your identity, we have certain capabilities in GKE in terms of IAM, audit, logging, and networking that we implement to support and reduce. For example, you might have hardened OS cores, or you might have shielded VMs or shielded containers to prevent you from making certain OS changes, things like that. But essentially, it's about the fact that even when you're using containers, you're often still using third-party products as a part of the build of the applications running in the containers. So being able to make sure that you can accurately and each time it's deployed, monitor and analyze the binaries that are going out for any new threats, because threats happen and fixes to threats happen every day. So what you deployed last week, there may be a threat that was identified and resolved, and then in the case of binary authorization, it would identify that and pick it up and then flag it. And then at that point, you can decide if that threat warrants you making a change to the code, to the container or not. But at least and it would show up in, it would show up in whatever dashboard you should be using if you're using monitoring and logging tools, systems like that. When you look at sort of a GKE security capabilities, at a high level, as I mentioned before, there's multiple areas where Kubernetes and security has to be identified. If you look at the infrastructure, you have to look at the nodes and ability to making updates and are those updates being validated. So under infrastructure security, there's things like secret encryptions with key management services, container optimized OS, which is Google's OS of choice when running containers, and it's shielded GKE nodes, so that the VMs that are running the containers have been shielded. That's from an infrastructure standpoint. When you look at it from a standpoint of network security, you have STO for service mesh and the security features built into STO. You have network security policies that you can apply to, for example, prevent ingress from external IPs for certain VMs or certain nodes. You have privacy clusters where you might have private clusters that can only interact with your intranet, not your internet, from a networking standpoint. And then in the case of workloads, we have this concept of workload identity that we use to keep track of who has permissions to do things with different workloads. But at the container level, you also have container threat detection to look at some of the common threats that are and vulnerabilities that are happening at that level. You also have, I mentioned a couple of times, binary authorization, which is a managed service, and you can easily add that to your CI/CD pipeline, such that as you do your builds and you get to a point where you have a successful build of an image that you now want to deploy, it will, as a part of the CI/CD pipeline, one of the steps is to be run through binary authorization, and if you can identify policies in terms of which will it allow it to be deployed or not. You also have the ability to set up separate sandboxes to isolate bugs you find, so that you can easily set up and deploy, even if there's a problem or some type of threat. you set up the sandbox, you deploy it to the sandbox, and then you run a battery of security tests to be able to validate and identify which teams have to respond to that, things like that. And then you also have the ability to set up configuration policies in your clusters. For example, you may decide that you're using namespaces, and in your namespaces you may have dev, test, prod, and prod has certain policies because it's a production that are more that are tighter versus dev and test, where the developers may have more latitude in terms of how they access and work with Kubernetes, what commands they run, things like that. And in the higher level namespaces, you can remove those capabilities so that you have more ability to validate. So those are some of the things that we typically implement. I don't have a demo, but I can show some of those in a later session if need be. But if you think about some of the best practices that we recommend, and these are, I think, very much generic. Maintaining the latest version of Kubernetes so you get all of the security patches and you're up at the right level, so that you're at the most secure level from at least base security Kubernetes standpoint. Setting up RBAC permissions at the namespace level, and by role, and identifying, having the different users, the developers, the testers, the operations teams, are being monitored and also being permissioned by role, right? So developers have the ability to do certain things in certain namespaces or environments. Likewise, operations may have only read access in production, or limited write access when it needs to be provided, maybe as a tier 2 support person. I hesitate to use super user anymore. Limited the surface of attacks. In some cases, you may separate your clusters, and this is more architecture and cluster design, but you may separate your clusters by threat level, where you have certain databases and other microservices that touch key databases are as private clusters, as we talked about earlier, and to eliminate the ability for external parties to actually access them in any shape or form without going through your other higher security levels, things like that. One of the capabilities I'm going to mention is in Google is a product called Security Command Center. It's based on some of the best practices for security, some of the things I mentioned already. It monitors your inventory management. It finds issues, concerns. There's a free version, and then there's a premium version. It looks at the API integrations and security detection. It's a console dashboard plus all of the different monitoring capabilities that allow you to bring some of the things that we talked about, or I mentioned earlier, into one single pane of glass, as someone mentioned, and that you can then manage your security posture for your GCE, your Google projects in a single viewpoint, things like that. So I'm going to stop here. Any questions?
Yeah, there was one question as we're finishing up. Can you confirm that your tools are both FERPA and HIPAA compliant?
I believe they're FERPA compliant, but I think HIPAA, it depends on the tools that you're using in terms of, are you referring to the DevOps tools like the build and deploy, cloud deploy, cloud build, binary authorization? What I would suggest is that person, if you can give them my contact information, I can follow up with them directly. And there's some papers and white papers I can share with you as well, that can be posted in, along with this presentation on those HIPAA and FERPA, so that you can see exactly which tools are supported, compliant, and their level.
Good.
Does that make sense?
Yep, I'll take care of that. I'll make sure you and Mike, I'll email both of you so we get that covered. So we've got another 5 minutes or so. So if you could highlight some of the key takeaways, that would be great, Reedy.
That makes sense. Yeah, I think, from my standpoint, I think that the key thing that is going forward from a security standpoint is, security can be thought of as certain products that you can implement to prevent threats. It can also be thought of as certain teams and their responsibilities. And in DevSecOps, it's more thought of as everyone has a part to play in security, that security is a part of every element of every step along the way of your journey, from the requirements through to operations, and that there's a feedback loop of monitoring, logging, and analysis that's done, as well as artificial intelligence, looking for threats and looking at patterns, that many of the successful organizations employ in order to improve and increase their security posture as they go forward. I would also say that depending on the cloud and depending on the nature of the application, you may need additional tooling like a security command center or other tools. There's a lot of third-party tools and capabilities that integrate with them to provide you with a single pane of glass, right? Aqua, Capsule, some of these systems have capabilities to, from application performance monitoring capabilities to help you alert on different, taking different metrics or SLOs and bringing them together to identify problems faster. In many cases, when a security breach happens, you're inundated and flooded with data. I mean, the whole purpose of the denial of service is to just flood your system so that you can't respond, and it brings them down. So being able to collect the data and analyze it quickly to identify the signals and also the signatures of some of these threats so that you can act appropriately is the takeaway from a DevOps. It's tools, it's people, and it's a process. And oftentimes, today you have to sort of pull it together yourself. But I think that's the key message. It still goes back to a holistic view of attacking these threats.